We start now miscellaneous exercise. Question number 1. Function f is defined in this way. It has two different formula. If x is from 0 to 3, then use x square. And if it is from 3 to 10, then use 3x. The other relation g is in this way. If it is from 0 to 2, then use x square. And if it is from 2 to 10, use 3x. Now question is, you show that f is a function. You show that f is a function, but g is not a function. So here you need to show that in g that if you have one member, then it must have two different images. So if you observe at this point 2 is common in both. If I use this 2 and if I use this formula here, g of 2 is 4. And if I use this 2 here and if I use this formula, then 3 into 2 6. So here you are getting 4, here you are getting 6. So one member 2 has two different images. Therefore g is not a function. What about f? Let me see that. So here fx is this x square. X is from 0 to 3. And this is 3x. 3 less than or equal to x less than or equal to 10. If you choose any number from 0 to 3, then here square, here multiple of 3. So only you need to just look at this point, common point. So at 3, if you just see at 3, f of 3, if I use this formula, 3 square, which is 9. And if I use this formula, f of 3 from here, then 3 into 3, which is also 9. So you are getting same image. For all other x, for all x in the domain, you can notice that x will have unique image. For the other point, that's not a question. If I choose any number, you square it. If I choose any number, it is just 3x. So f is a function here. F is a function here. For the other one, for g, you know, here gx has this formula. X square if I use from 0 to 2. And here 3x if I use from 2 to 10. So if I use these two and if I place here, so g of 2 will be 2 square, which is 4. If I use these two, so 3 into 2 different formula, which is 6. So different images. So 2 has two different images. And therefore g is not a function. It's just a relation. Not a function, it is a relation. Next question, fx equals to x squared, and you are asked to find, the question is, find f of 1.1 minus f of 1 upon 1.1 minus 1. F of 1.1 means put 1.1 in the formula of the function. So 1.1 the whole square. F of 1 means put 1 here, so 1 square upon 1.1 minus 1, and you just simplify, you will get the answer. Question number 3 here, you are given fx equals to x square plus 2x plus 1 upon x square minus 8x plus 12. So now here we want the domain of this function. Now, you know, as far as domain concerned, for domain we did it twice, one more time. Domain means find all x, find x for which fx is possible. that is defined. Possible means fx is defined. Now you have division of two functions. When you have division of two functions, you just need to assure that the denominator function should be non-zero. This should be non-zero. So what we'll do, we find x for which denominator equals to 0. So x square minus 8x plus 12 equals to 0. Factorize this, you know x minus 6 and x minus 2. These are the factors. So either x is 2 or 6. So if I put 2 here in the function, you will see that this is 4, this is 12, 16 and minus 16. So this becomes 0. Even if I put 6 here, this will be 0. So we need to drop these two numbers from the domain. For any other real number, this is not a question. So what will be the domain? Your domain will be R minus other than 2 and 6. How we got this? You got all numbers for which function denominator becomes 0, and you drop those numbers from the all real numbers. For other real numbers, there is no question. For example, here if I take this, fx equals to 1 upon x minus 1, then what do you think? What's the domain for this function? So domain would be all real numbers. Now where this becomes 0, at 1, you know if I put 1, 1 minus 1 is 0. So we drop 1 from this. So domain will be all real numbers other than 1. This is the way of getting the domain. If I put here 0, not a issue, 1 upon 0 minus 1. If I put 2, not a issue, 1 upon 2 minus 1, you can do. If I put 1 by 2, not a issue, 1 upon 1 by 2 minus 1. The only problem arises at 1, so here domain will be every real number other than 1. If I take one more function like this, suppose I have x upon x minus 4. So what will be the domain of this function? So now you can answer it very easily. All real numbers where this becomes 0 at 4. So other than 4. This way you can get domain of different functions. So for this function, we want your first domain and then range, both the things. Now we did it earlier, one more time. You know domain means possible values of x. So when you have root of some number, then the number should be greater than or equal to 0. So for domain here, that inner expression must be greater than or equal to 0. If you have a negative number, a minus 2, then this is not possible. So this has to be greater than or equal to 0. That means x must be greater than or equal to 1. So you can say that the possible values of x will be here more than 1. So therefore domain of this function would be 1 or more than 1. That is 1 to infinity. If this is 1, then all these numbers starting from 1 to goes to infinity. So this is a domain. If I pick up any number from this 1, 2, 3, 2.5, this is defined. But if I choose, for example, any number less than 1, for example, if I taken 0.5, then you can notice that 0.5 minus 1. So inside the root you will get a negative number, which is not possible. This, if I have here negative number, suppose minus 0.5. So this is not possible. So inner number should be greater than or equal to 0. Get x from this. Domain means possible value of x. Remember, this is the domain. So x will be 1 or more than 1. Now range again you recall. Range means possible values of the function. Possible values of fx. That's called the range. So for every x, you know, you can take 1 also. So this is 0. So root of x minus 1 is always greater than or equal to 0. It can be 0 also, remember. If I put 1, it is 0. You are not going to put less than 1. If I put 2, it is always positive. So you can say that fx is always greater than or equal to 0. So what's the range? Range would be close interval 0 starting from 0 to infinity. If this is 0, then all these numbers So 0 to infinity. This is the range of the function. Next is similar question. I'll go to question number 6 here. So there it is given in form of ordered pair. It means fx equals to x square upon 1 plus x square. This is given to us. You are given question in form of ordered pair. I wrote in form of formula fx equals to x square upon x square plus 1, and function is from R to R, real numbers to real number. This is called domain and this is called codomain, you know. We want range, this is the question. We find range, this is the question. Range means, you know, possible values of fx, possible values of fx. That's called range. Function, images. Function means images, fx means images, possible values of fx. So here, as far as function concerned, if you notice, you observe this much. Observe that 1 plus x square is always greater than x square for every x. You can notice this much. This is always true. 1 plus x square is always greater than x square. I need x square by this. So if I take on the other side, x square upon 1 plus x square. So that is, I'm trying to tell you is, x square upon 1 plus x square is always less than 1. You choose any number. If I put 0, 0 by 1. If I put 2, then 4 upon 5, and so on. And being square here, this is also square. So here, if I put 0, then it will be 0. So x square upon 1 plus x square is always greater than or equal to 0. This answer will be never be negative, and it is always less than 1. Right. You try for any number. If I put 0 itself here, then 0 by 1, it will be 0, or for any other number it is less than 1. So from this you can say that the function is less than 1 and greater than or equal to 0. So therefore range would be close interval 0 to open 1. That is, 1 is not included. If I try, for example, here, see, if I take any number, for example, you just notice here, if I take f of 1, 0, for example, 0, 1 plus 0, it will be 0. If I take 1 here, then 1 upon 1 plus 1. So this is 1 by 2. If I take 2 here, 2 square upon 1 plus 2 square, which is 4 by 5. Again less than 1. If I take even minus 2, this is 4 upon 1 plus 4. This is 4 by 5. This is less than 1. You see, each of these is always less than 1. It can be 0 also and positive. So that's why we have concluded that here range equals to close 0 you are getting. You can see 0 to less than 1. So open interval 1. You know types of the interval. 0 to 1. So this is a function where range is, as I explained here, 0 to 1. This is a general proof here. Next question is about those 4 operations. We find f plus minus g, f into g, and f by g. So domain of f plus minus g and f into g, which you know, it's from R to R. This is not difficult. What is f plus g at x? You know it is fx plus gx. What is fx? X plus 1. What is gx? 2x minus 3. So finally you are getting 3x minus 2. So therefore f plus g at x equals to 3x minus 2. Similarly you can do the other one here. I'll go for f by g. Now for f by g, codomain will be R only. You know f by g at x is fx upon gx. What is fx? X plus 1. What is gx? Gx is 2x minus 3. When you do division, you need to be little careful. Do you have any x for which this becomes 0? So gx becomes 0. It implies 2x minus 3 will be 0. So obviously x will be 3 by 2. So this is the value of x for which gx becomes 0. So this x we need to eliminate from the domain. So what's the domain here? R minus 3 by 2. This is the domain of division of two functions. You drop all values of x for which gx becomes 0. So you know if I put 3 by 2 here, then this will be undefined. So this is the formula for function here, x plus 1 upon 2x minus 3. But domain is not just real number. All real number for which this becomes 0. So it becomes 0 at 3 by 2. So I've eliminated 3 by 2 from this. Next question. You are given a function in this way, which is in form of ordered pairs. This means f of 1 is 1, f of 2 is 3, f of 0 is minus 1, f of minus 1 is minus 3. Now, formula of the function also you are given. You are asked to find a and b. Now, it's a very simple question, but it's an important question. Formula for function you are given. Function you are given by this relation. Now recall what's the meaning of this. This means f of 1 is 1. Now you need to get two unknowns. So I'll use two ordered pairs. Any two you can use. I'll use this and this because here 0 is there. So 1 comma 1 belongs to the function f. It means if I put x equals to 1 in the function, then the value of the function is 1. Now what's the meaning of this? What is the f of 1? Put 1 here. So a plus b equals to 1. This is one equation. Putting x equals to 1. So a into 1 plus b this. And I'll use this 0 comma minus 1 belongs to f. What is the meaning of this? F of 0 equals to minus 1. Now put x equals to 0 here. So what will get? A into 0 plus b equals to minus 1. So b is minus 1. So b is minus 1. If you take on the other side by 1, if I put minus 1 here, a is 2. So these are the possible values. Now there is nothing special about 1, 1 and 0, minus 1. You can use any two ordered pairs. Why you need to use two ordered pairs? Because you want to get two unknowns. You can use this and this, you can use this and this, you can use this and this. So you'll get two equations in a and b, and then you solve them. We got b here, which is minus 1. Put here. If I take on the other side, a is 2. So these are the values of a and b. So your relation R from n to n, natural numbers to natural number, given as, this is from relation, remember, R equals to, you recall relation is set of ordered pairs a comma b, where obviously a and b from natural numbers, and you are given that a equals to b square. That means this first number is the square of this. So here if I choose 1, for example b is 1, then this will be 1 square, so both are equal. But if I choose 2 here, then a should be 4 here. So if I go to first question here, question is this statement is true or not. So a comma a belongs to R. Is this true? This is the question. Now, so this means this condition should be true. So you have Here a is equal to a square. So you know that this is true on n only for 1 is true only for n a equals to 1, not for all. In the question it is written for all. Is this true for all a and a belongs to n? Now if I put 2, this is not true. 2 equals to 2 square, not true. So it's true for only one but not all. So therefore the first statement is not true. Remember, this is not true. In the question it is written for all a belongs to n. Remember, here it is true only for 1. 1 equals to 1 square. If I put 2, then here it is 4. 2 equals to 4 is not true. So it's not true for all n. Therefore it is in general not true. Question number 10. Here f you are given as a set of ordered pairs. A is this, B is this. So here 1, 2, 3, 4, 2 all are from A. 5, 9, 1, then 5 and then 11, these are from B. So you can see that F being subset of A cross B would have 4 into here 6, so 24 ordered pairs. So F is a subset of A cross B here. Here 4 members, here 6 members. So out of 24 you have 6 ordered pairs. So F is a subset of A cross B. So F is a relation. F is a relation from A to B. That was the first question. So answer to the first question, is this first one is true? So yes, it's true. It's a relation. Second question, is F a function? That's a question. So you know it very well now. By observation, you can see that 2 is associated with 2 different members. 2 is associated with 9 as well as 11. So 2 has 2 images. And therefore here F is not a function. It's a relation but not a function. You know, every relation need not be a function. So next is again same question. F is defined as ordered pairs like this: AB, A plus B, where A and B both are integers. So you can choose any integers. The question is F a function? That's the question. Is this relation represent a function? Is the question. So if you think for a while, suppose I'll take A equals to 2 and B equals to 2. So we'll get 2 into 2, 4, and here 2 plus 2, 4. If I take A equals to 4 and for example B equals to 1, this can be any integers. So here A into B, 4 into 1, 4. Here 4 plus 1 is 5. So immediately you can see that 4 is associated with 2 different members. 4 goes to with 2 different, 4 and 5. So from this you can say that not a function. Not a function. You can find many such ordered pairs, number of ordered pairs, but one is sufficient. You can try some more if you want, but here one example is sufficient. 4 associated with 2 different members, 4 and 5, therefore not a function. Next question, 12th number. There you are given a set having these members 9, 10, 11, 12 and 13. And F is a function from A to N, natural numbers. A is domain and N is codomain. And definition of the function is F of N is the highest prime factor of N. And question is, we find range. This is a question. We find RF, that is set of images. Here domain is finite set, so we take one by one members and we put here. So first f of 9. Range means set of images. Now highest prime factor of 9. Now what are the factors of 9? You know, 1, 3 and 9. Among these, which are the prime? This is the only prime factor and it's the highest one, so f of 9 is 3. Highest prime factor, the 1, 3, 9 and factors, but 3 is the only prime factor, therefore f of 9 is 3. Go to 10. So write the factors of 10. What are the factors of 10? 1, 2, 5 and 10. Among these prime factors, you know, 2 and 5 both have prime and highest one is 5. So f of 10 is 5. Highest prime factor, 2 and 5 both are primes, but the bigger one is 5. Go to 11. You know, 11 itself is prime, so it has two prime factors, 1 and 11. So 11, 1 is the highest and it's prime. Go to f of 12. You write the factors of 12. What are the factors of 12? That is 1, 2, 3, 4, 6 and 12. These are the factors of 12. Among these prime factors, 2, 3. These are the prime factors. And highest one is 3. So f of 12 is 3. 13, you know, it's a prime number. So 13 is highest prime factor. So therefore RF will be here. Range will be set of images. That is 3, 5, 11 and 13. These are the images. 3, 5, 11 and 13. This is the range of this function here.